You might picture Neanderthals as cavemen gnawing on bones around a campfire. Which wouldn't be inaccurate. But Neanderthals may have also dined on roasted vegetables and known a bit about medicinal plants too. So says a study in the journal Naturwissenschaften, The Science of Nature. Researchers analyzed hardened dental plaque from 5 Neanderthals found in El Sidrif cave, in northern Spain. Yes, 50,000-year-old dental plaque. And they found a lot lurking between the teeth. Like evidence of nuts, grasses, and green veggies, chemical traces of wood smoke, and tiny, intact starch granules, proof Neanderthals ate their carbs. And in one individual, they detected compounds found in the medicinal herbs, chamomile and yarrow. The herbs have no nutritional value, and since Neanderthals did have the gene to detect the herb's bitter taste, the researchers speculate that the cave dwellers were munching on them not as food but to self-medicate. Not too far-fetched, they say, because primates like chimps also use medicinal plants. Luckily for the scientists doing this detective work, Neanderthals may have known a thing or two about medicine, but they didn't get regular checkups at the dentist. You just bought peanut butter. You chose the jar because, well, you've always eaten the crunchy variety. In reality, however, something else may have influenced your choice. The product you picked was centrally located on the store shelves. Researchers tracked eye movements of 67 subjects, scanned a 3x3 matrix of fictitious brands. The tracking found that consumers tend to focus on the objects in the middle specifically, 5 seconds before they make their choice. And they do this for all kinds of products, from vitamins to online movies. Also, subjects continued to go for the centrally located brand even if the product was not in the middle of their specific visual field. So it's not in reference to one's view, it is literally about the product being central within the entire shelf layout. Past studies have shown that people tend to make a lot of choices based on central locations, like choosing the middle bathroom stall in a public washroom, a middle seat at a table, or even the middle items in a series of arbitrary objects. The test consumers had no conscious awareness that they had chosen centrally located brands. Makes you wonder what you've taken home without realizing why. Ronald Cotton went to prison for rape. The victim picked him from a lineup, convinced she was accurate. She picked him again years later, when his case was reopened. This second lineup included the actual rapist. After 11 years behind bars, Cotton was later exonerated by DNA evidence. Experts say that the current lineup format pressures witnesses to identify a suspect, even when they lack competence. So researchers are trying to improve the accuracy of such identifications. One recent study had more than 900 participants watch a short film of a staged crime. Up to a week after watching the film, the viewers looked at photos of suspects one at a time, and rated how confident they were about each one's guilt. Half of the participants could take as long as they wanted to look at the photos. The other half had to decide within a few seconds. And the fast group was up to 66% more accurate. The study is in the Journal of Psychological Science. Strong memories are accessed more quickly than weak memories, which may explain why choosing fast tends to mean choosing right. Another factor that's putting the standard police lineup itself on trial. One day the banana is perfect. Bright yellow, firm, flavorful. But even within that same day brown spots appear on your perfectly ripe banana, its flesh turns mushy, and it's destined for the compost or at best, banana bread. But scientists are developing a way to extend the life of ripe bananas. It's a spray-on coating made from chitosan, a substance found in crab and shrimp shells. The new gel can be sprayed on bananas to slow the ripening process by up to 12 days. Like other fruit, bananas remain alive after being picked and they actually continue to respire. This means they take in oxygen and release carbon dioxide. The more the banana breathes, the faster it ripens and then rots. Bananas ripen more quickly than most fruit because they don't naturally slow the respiration after being picked. In fact, it speeds up, causing bananas to become mushy. Chitosan not only kills the bacteria on banana skin that then leads to rot, it also significantly slows down the respiration in the first place. So bananas won't drive you bananas. It's a dirty job, but 2 NASA spacecraft are ready to do it. On August 23, NASA plans to launch 2 spacecraft into the radiation belts around Earth. The twin radiation belt storm probes will investigate high-energy particles held in place by Earth's magnetic field. Those fast-moving protons and electrons form 2 bands known as the Van Allen radiation belts, after physicist James Van Allen, who discovered them in 1958. The 2 NASA probes will study how the belts formed, and what makes them swell up from time to time. The outer radiation belt in particular can change quickly in response to the sun's outbursts of charged particles, also known as solar storms. The Van Allen belts are a nuisance to some spacecraft, and they could pose a hazard to future manned missions as well. But the radiation belt storm probes will call those harsh environs home. The spacecraft will fly through the belts for 2 years, measuring charged particles, plasma waves, and magnetic fields in Earth's vicinity. NASA hopes that the mission will help illuminate the complex physics of the stormy near-Earth environment. And, perhaps, help future spacecraft weather that storm. In electronics, there's an understanding that silicon and other elements are responsible for bringing our gadgets to life, while plastic serves as the supporting structure. But what if that plastic could be both the brains and the brawn? Better yet, what if plastic was pliable enough to form all sorts of wearable electronics and even implantable medical devices? In fact, electronics made from conductive plastic have been in the works for at least a decade. One of the difficulties has been overcoming a loss of conductivity when plastic electronics are stretched too far. A team of researchers from the US, South Korea, and China say they have found a way to keep an electrical connection, even after stretching their specially made plastic more than 4 times its normal size. The key: make a highly porous polymer, and then fill those pores with liquid metal. Imagine these 3D stretchable conductors being used to make artificial eyes that restore vision or synthetic skin that monitors blood glucose levels. A bit out there, I know, but science has a knack for catching up with science fiction. Vaccines are desperately needed in the developing world. Even when they're available and inexpensive, there's still a major problem: most vaccines need to be refrigerated. Reaching the relevant populations often means traveling to areas where electricity and refrigeration are spotty at best. Nearly half of the vaccine doses around the world are lost to the heat. Also, the cost of refrigeration contributes to about 80% of the cost of the vaccines. So silk experts at Tufts University have come up with a potential solution: encase the vaccines in silk protein. Silk proteins contain nanoscale pockets that can hold and protect biological compounds. Inside the silk protein wrap, the compounds stay biologically stable. In the lab, they were able to stabilize the measles, mumps, and rubella vaccine for more than 6 months at a variety of tropical temperatures. The technology also worked with antibiotics. Stored at a month at temperatures reaching 140 degrees Fahrenheit, the antibiotics kept their potency. The research is in the Proceedings of the National Academy of Sciences. If the lab results hold up out in the world, the silk safeguard could save billions of dollars and millions of lives. You've probably noticed you're more likely to catch a cold if you pull a lot of all-nighters. But lack of sleep can also compromise your immune system's response to vaccines. And in some cases, make the shots useless. So says a study in the journal Sleep. Researchers gave 125 healthy, middle-aged men and women the hepatitis B vaccine, a 3-part vaccine given at 1, 2, and 6 months. And during that time, volunteers tracked their sleep habits. 6 months after the final booster, researchers took blood samples to see if the patients had rallied sufficient numbers of antibodies against Hep B. 18 patients had not. The vaccine had failed. Turns out the vaccine was almost 12 times as likely to fail in volunteers who regularly slept fewer than 6 hours a night compared to those who snoozed more than 7. Makes sense, because previous studies have shown that sleep deprivation cuts numbers of B and T cells, which coordinate the immune system's attack on bad guys. So remember, vaccines aren't magic. You still need a good night's sleep to give me a fair shot. You've probably heard of peanut or shellfish allergies, but a meat allergy? Not as common. Even weirder is what might be causing it: tick bites, according to a study in the Journal of General Internal Medicine. A few years back, folks started showing up in emergency rooms in the southeast U.S. with hives, swelling, or worse, anaphylaxis after eating red meat. For this study, researchers looked at 3 of those cases. And they found that tick bites, specifically those of the Lone Star tick, seemed to be the cause. The bitten victim's immune system appears to become sensitized to food allergies, or substance called alpha-gal. And whereas all the major triggered by proteins, the culprit here, alpha-gal, is a carbohydrate. Alpha-gal's found in the meat and fat of hoofed mammals, like cows, sheep, or pigs. So eating a burger can expose you to alpha-gal, which activates antibodies and leads to the release of histamines. Researchers say something similar to alpha-gal in the tick's saliva may set off the immune system, which then goes after the alpha-gal in meat and leaves a steak lover ticked off. Are human beings inherently generous or selfish? A new study finds that when people have to make the choice instantly, their first impulse is cooperation, which indicates that generosity is innate. Only when they have more time to consider their choice do they behave more selfishly. The research is in the journal Nature. In the study, researchers ran several tests in which each participant in a small group received money, and then had to decide how much to invest in a shared group fund. Them or time people had to choose how much to donate. The less they gave, subjects told they had to make a decision within 10 seconds even gave more than others who were told they had to wait the same 10 seconds before deciding. Because snap decisions are based on intuition, the researchers concluded that generosity is the intuitive human response. But given time, we can reason our way to a more selfish decision. This intuitive cooperation might be either genetically hardwired or cultural construct. Either way, next time I run fundraiser, I'm bringing a stopwatch.